Hello everyone, my name is Minazia binti Zablis, F1041.
My name is Nurjan Najwa binti Alizad, F1067.
And my name is Siti Nurhaliza binti Kamar Zaman, F1172.
My name is Cik Wana Shamila binti Syawal Azri, F1131.
Today we would like to explain about our mini project.
Hi, my name is Shamila and I will be the first presenter for our group. Let's move to the first question that needs a solution to a problem involving stacks, a type of data structure. The question is, Aiman joined a programming competition in his faculty and he has 1 week to solve a problem. Aiman's task is to reverse the word entered by the user and display the characters in reverse order. For instance, if the user enters ALI, the program should output ILA. To solve this, Aiman asked for help constructing a program that uses a stack to reverse the entered word. So before we dive into the code, let's discuss why we are using a stack to reverse the word. A stack is a data structure that follows the last in first out principle. This means the last element added to the stack is the first one to be removed. So, if we add each character of the word to a stack and then remove each character one by one, we will get the word in reverse order. Using a stack makes it easy to reverse a sequence by pushing all elements in and then popping them out. You can look at the code to show in the slides to see how this works. And let me explain each part of this code. The first one is getting the word. So we take input from the user and we store this input in a string variable called word. Pushing characters to the stack is we then look through each character of the word, and for each character we use the push function to add it to the stack. Reversing by popping from the stack. After all characters are pushed onto the stack, we use a while loop to pop each character from the stack and print it. Since the stack is last in first out, characters are popped in reverse order, which gives us the reverse word. So, let's look at an example to see how this code works. So, we input suppose a user enter is the word Ali, and each character is pushed onto the stack in this order. Which is ALI. And popping from the stack is the stack's LIFO nature means the character come out in reverse order when popped. The output is ILA. So, you can see the output that we put in the slides. In summary, we use a stack reverse the word because a stack follows the last in first out order. We push each character of the word onto the stack and then pop each character to print it in the reverse order. This is a great example of using a stack to solve a real-world problem in programming. That's all from me. I will pass this presentation to my friend Haliza.
Hello everyone, today I will be explaining a C++ program that I created to solve the question 2. For a food order system, in this task we ask to how order a handle in restaurant where order are processed on a first in first out or FIFO basis. Imagine a restaurant where order come in one by one. The restaurant need to manage these orders so that the first order placed in the first one to be complete and delivered. To do this, we are use queue data structure which follow the FIFO rules, meaning the first customer line gets served first. So let's look at the code step by step. For the first one, we include the necessary labels for input or output operation, stack, queue, and string. The second one, define the customer structure. Next, we create a customer struct. This struct contains a string name order to hold each customer order. Third one, the order system class is where most of the process happen. Inside this class, we have a private queue named customer queue, which hold each customer in line. Public method to add customer, add order, and process order. Adding customer, the add a customer function push a new customer to the queue. For the 5th one, adding orders, the add order function take an order as input and add it to the most recent customer's order. 6th one, process order. The process order function remove the oldest order from the queue and proceed. It pop order one by one for each customer and display them for printing order. For 7th one, main function. In the main function, we test our system by adding customer, adding order to each customer, and processing each order in sequence. 8.1 order explanation. The output will show each order being complete in the order they were placed, ensuring the customer who order first get their food first. For example, complete order fries, completing order burger, completing order pizza. So here the conclusion that I can give you guys. This program effectively use a queue to manage multiply customer and their orders in the first in first out manner. By using a stack for each customer order list, we ensure that we can add multiple items to each customer and process them efficiently. This setup mimic a real-life restaurant where each customer is served based on by their arrive. So that's all for me. Thank you.
Assalamualaikum, my name is Nur Jonathan Najmah binti Alizan. My matrix number is F1067. So I will explain to you about question 3. So in our code, we define a node structure to represent each element in the tree. Each node has 3 parts. First one is a data file that stores the value of the node, a pointer to the left child and a pointer to the right child. When we create a new node, we assign it a value and initially set its left and right children to null since it doesn't have any children yet. The next step is the insert function, which allows us to add new nodes to the BST in the correct order. Here's how the insert function works. First, we check if the roots of the tree is empty. If it is, we create a new node as the root. If the root isn't empty, we compare the value we want to insert with the current node. If the value is less than the current node's value, we move to the left child. If the value is greater, we move to the right child. We repeat this process until we find the correct position to insert new node. This approach ensures the tree remains sorted with smaller values on the left and largest value on the right. Now we talk about find minimum functions. This function is useful during relations when we need to find the smallest value in a subtree. In a BST, the smallest value is always found at the leftmost node. So to find the minimum, this function starts at the root of a subtree and keeps moving to the left child until it reaches a node with no left child. This leftmost node contains the smallest value. Next, we have the delete functions, which remove nodes with a specific value from the BST. The delete functions works by the first searching for the node with target value. Once we find it, if the node has no children, we simply delete it. If the node has one child, we replace it with its child. If the node has 2 children, we replace it with the smallest node if it's right subtree. This is where the find minimum functions come in handy. By following this step, the delete function ensures that the BST properties are maintained with smaller values on the left and largest value on the right. The in-order traversal functions allow us to view the value in BST in ascending order. So here's how in-order traversal works. We first visit the left subtree of each node, printing all the smallest value. Then we print the current node's value. Finally, we visit the right subtree, which contains the larger values. Next is the main part of the program. We put everything together. We start by creating an empty BST. Next, we insert several values to build the tree. We then perform an in-order traversal to display the initial structure, and we delete a few nodes and perform in-order traversal after each deletion to show how the BST updates. This step-by-step process demonstrates how inserting, deleting, and traversing by the BST keeps the data sort and maintain efficient performance. So that's all from me. Thank you.
Hi, I'm Lena. I will continue with question 4. So question 4 is about searching. Searching process in data processing context is a process to find the location of data in a list or table given. It's being done by comparing each data item with the search key. First, we have linear linear search. It is used whenever the list is not ordered and used only for small lists or lists that are not searched often. In linear search, we start searching for the target at the beginning of the list and continue until we find the target or we are sure that it is not in the list. So let's look at our question. Our target key is 52. So the first step is we look at each index, starting from the first one. So we look at index 0 and the element or data, should we say, in index 0 is 8. So 8 is not equals to 52. For the second index, which is index 1, the data in it is 11. 11 is not equals to 52. In index 2, the data is 19. 19 is not equals to 52. So we keep on going until we find the target key. In index 3, it's not 52, it is 25. And index 4, it is 34. And index 5, it is 47. And index 6, it is 52. So finally, we have found our target key. So the search ends here. And the next search is called binary search. Binary search is used whenever the list starts to become large. The binary search starts by testing the data in the element in the middle of the array to determine if the target is in the first or the second half of the list. If it's in the first half of the list, we do not need to check the second half. If it's in the second half, we do not need to check the first half. In other words, we eliminate half the list. So let's look at our question. Our target key is the same, 52. So we first determine the first index, middle index, and last index. So our first index is index 0. The data in it is 8. Our middle index is index 4. The data is 34. And our last index is 9. The data in it is 60. So we look at the middle index, which is index 4. And the data in it is 34. So our target key, 52, is larger than 34. So we do not have to look at the first half of the list. The next step is the same. We repeat, determine the first, middle, and last index. So the first index is 5, middle is 7, and last is 9. So we look at our middle index, which is 55. So our target key, 52, is smaller than 55. So repeat the same thing. This time the first index is 5, the middle index is also 5, and the last index is 6. So we look only at the middle index. The middle index is 47. So in this case, 52 is larger than 47. So for the next one, since we are only left with one index, so the first, middle, and last index are all 6. So in 6, the data is 52. So we have finally found our target key. So the search ends here. And that's all for question 4. So that concludes our mini project presentation. And thank you for listening.